So everyone completed? I cross verified the what? 20 by 9. Okay, listen. So this is the question, right? I need to find the current flowing in the circuit. So we have taken that, so I is flowing in this direction. So which means I splits into two parts. It's not two equal parts, it has been split into two parts. So if this is I1, this one will be I minus I1. So in this also I1 will be there, right? No. So we have taken the path from here to here, and again this is my second path. So what will be the equation? So initially this is 0 volt, no? So 0, then this one plus 2, then minus 3i. Which one? This one 12. Okay. So 12, and this is 3i, and when I come to this point, this one will be minus of 3 minus I plus, so I minus 1, I minus I1, then plus 0 equals to 0. Any doubt here? We have taken this also 0 and this also 0. Okay. Then can I expand this one? 12 minus 3i minus 3i plus 3i1 will be equals to 0. So which is nothing but 12 minus 6i plus 3i1 equals to 0. This is my first equation, right? What will be the second equation? Starting from this point, which is nothing but 0 plus 12, then minus 3i. In this point, it is minus 2i1, this one minus 10i1 plus 0 equals to 0. Any doubt here? So this one 12 minus 3i1 minus 2i1 minus 10i1, which is nothing but which one? Oh, this is minus 3i. So minus 3i, and this is minus 12i1 will be equals to 0. This is my second equation, right? So can I eliminate something here? Yes or no? I will take this equation 12 minus 6i plus 3i1 equals to 0. So can I multiply this equation by 2? First equation. If I multiply, what happens? 24 minus 6i1, I mean 6i minus 24i1 will be equals to 0. So minus plus plus. Not getting. Which one? No issues, we can get. I need to get both the current. What is the current flowing here and what is the current flowing here? I1 also I need to find, I also I need to find. Okay. So what happens here? Minus 12. This and this will get cancelled off. And what about this one? Plus 27i1 will be equals to 0. So 27i1 will be equals to 12. So I1 will be equals to 12 by 27, which is nothing but 4, and this is 9. 4 by 9 I1. So got I1 as 4 by 9. Then okay, we'll see what is about I. So can I take this equation only? So 12 minus 6i plus 3 times, what is that? 4 by 9 equals to 0. So 12 minus 6i 1 times, and this is 3 times, plus 4 by 3 equals to 0. So 12 plus 4 by 3 equals to 6. I have taken the minus 6 to the other side, which is nothing but 6. So this is 36 plus 4 divided by 3, which is equals to 6i. So 40 by 18 equals to I. So this is 20 times, and this is 9 times 2. 20 by 9 equals to I. So we got the both answer. So I1 is nothing but 4 by 9 and I is nothing but 20 by 9. If you have not completed, you can take this. Already completed. So we'll do 2 more different questions and we'll go for the next topic. Done. Completed. Okay, this is the circuit now. So they have given that I1 current is flowing in this direction and I2's current is flowing in this direction. So when this junction is there, this is I1 and this is I2. What about this one? I1 plus I2 going together, no? This current is coming here and this current is coming here. So I am clubbing together. So let me take this is my junction, like the first point, and this is my second point. So I can take this as a circular loop, this one, and can I take this as my circular loop? Two circular loop I have taken. So can I get the equation now? Get the equation and find what is the current I1 and current I2 first. Start from this point and end at this point only. Completed? Done. What is the answer? I1 is equals to 1 and I2 5 by 3. Fine. Completed. Okay, listen here. So I have started from this point and going in this direction. So plus 2 minus minus 2 plus I am going, no. So which means 2. Then in the direction of the current, so minus 6 I1, and this one again it is plus 4 equals to 0. The next one, what about this one? 6 minus 6 I2, then plus 4 equals to 0. That's it. There is no other equation. From the first equation only I can get the value of I1, which is nothing but 6 minus 6 I1 equals to 0. So 6 I1 equals to 6, where I1 equals to 1. From the second equation, there is nothing but 10 minus 6 I2 equals to 0. 6 I2 will be equals to 10. So I2 will be equals to 10 by 6, which is nothing but 5 by 3. This is my current in I1 and I2. That's it. Two equation, two unknowns. From the first equation only we can get the first unknown. Second equation we can get the second unknown. Done? Completed? Okay, we'll go for the next question. Okay. So this is the question. I need to find potential difference, that is VA minus VB I need to get, and then what is the equivalent resistance. So equivalent resistance means nothing but I need to resolve it, either it is a series or parallel. I need to see and I need to resolve this question. Okay. So these are the complicated circuits, but on simple logic we can solve this. Listen carefully now. If I take a current I which is flowing, so it has been divided into how many parts? Which means I by 3, I by 3, I by 3. Got it? Now coming to this junction, again divided into 2 parts. Then I by 6. I by 3 divided by 2, no? I by 6, and this one will be I by 6. Again this one going here and divided into I by 6, I by 6. So this I by 6 and this I by 6 clubbing together and joining here, which means I by 3. Again this one is going here and it has been split into 2 equal parts, I by 6, I by 6. So what about this one? I by 6 coming here, I by 6 coming here, this one will be I by 3. And this I by 6 coming here, this I by 6 coming here, this is I by 3. So we resolved everything, no? The current. Any doubt in the current now? So if I travel either in this direction, I am getting 3 resistance, no? 1, 2, 3. I am traveling from A to B. So if I travel here, I3, I6, I3, I am crossing. If I travel in this direction also, I3, I6, I3. If I travel either any direction, I will come across I3, I6, I3. Once you can see now, whatever direction you want, you can go, but it should not be repeated. The direction should not be repeated. I can either go like this for B, from A to B, this direction, either I can go like this, come like this, again go like this. So I can reach B. So I can start like this, again coming like this, again reaching the B point. So you can see whatever the direction you want, but the direction should not be repeated. Once you see how many current we are coming across, like we come across 2 I by 3 and 1 I by 6. Cross verify it first. Getting the same thing? Yes. So if I travel anyhow, I can get the same potential, no? Yes or no? I can take a simple thing, I will travel like this from A to B. So first one is VA, potential. Then I am coming across the resistance in the direction of the current, so minus I by 3, let me take the resistance as R. For everything is equal resistance. Okay. Again coming to this point, in the same direction, I by 6 R, in this direction I by 3 into R should be equals to VB. So can I take VA minus VB is equals to I by 3 R plus I by 6 R plus I by 3 R. So I can take IR commonly outside, no, which is nothing but IR times 1 by 3 plus 1 by 6 plus 1 by 3. So IR, this is 2 plus 1 plus 2 by 6. Any doubt here? So which is nothing but IR into 5 by 6, which is nothing but I times 5R by 6. So this is my VA minus VB. So we got the first answer, VA minus VB. Now they are asking what is the equivalent resistance. So this is my equivalent resistance, 5R by 6. So R equivalent is equals to 5R by 6. So current is flowing I only, no? I have considered I only. So the remaining is resistance. So 5R by 6 is the resistance. So this is the one way to find the equivalent resistance. Either I can use the formula series or parallel, or I can use the potential difference formula also to get the equivalent resistance. Okay, you can copy down this one. When you can use this is like it should be a symmetry, like every resistance are equal here. completed. Still. Ampere, and this is 5 ampere, this is 3 ampere, and this is 4 ampere. What is I here? What is the value of I? 2. Yes, 3 పోతుంది. ఎక్కడ పోతుంది? 3 ఎక్కడికి పోతున్నది? 4. 16. 21 is the answer. 21. 26. No. 21 is the answer. Once you cross verify it. Can I say now? So 20 ampere is coming in. So which means 5 ampere has been went this side. Which means the remaining is 15. So in this point 3 ampere has went outside. The remaining will be okay. Now 15 is coming here and 4 also coming here. Which means 19 is coming here and 2 is coming here. Which means 21 is the answer. Understood? So the next topic is power across the resistor. Power across the resistor. Right on the first point. Whenever current flows whenever the current flows through a resistor, heat is lost. So the formula is the rate of heat lost, the rate of heat lost is equals to I square R, or else I can write this as V square by R also, or else it is V into I. So three formulas in terms of current and resistance, in terms of voltage and resistance, in terms of voltage and current. Okay, you can remember any one formula, it's enough, and you can rearrange this like V is equals to IR. By using this I can substitute the values. Okay, write down the question, or you can write the subtopic. I will tell under the subtopic the question. Bulb as a resistor, bulb as a resistor. Write down the first point. Bulb rated at 100 watt, bulb rated at 100 watt. The SI unit of power is watt, no? Bulb rated at 100 watt, comma 200 volt, means bulb act as a resistor, and the rate at which energy is dissipated, is 100 watt. Dissipated, which means the meaning is released. Comma when it is connected across 200 volt battery. Okay, so can you find what is the resistor for this question? Can you get what is the resistor for this question? Yes, question A. Yes. The first point is question, bulb rated at 100 watt and 200 volt, and I have explained the meaning of that question. How to find the resistor? 100 watt and 200 volt they have given. Volt, the power, the rate of heat lost. So power is equals to V square by R. Power is 100 they have given, no? And what about this one? 200 into 200 divided by the resistor R. So R will be equals to 200 times 200 divided by 100. So this and this will get cancelled off and the resistor is 400. So can you get what is the value of I? Value of I. We know value of V, we know value of R. Can I get V is equals to IR? Value of V is 200 and this is I into 400. So it is I is equals to 2 by 4, 1 by 2, it is 0.5 ampere. Any doubt? Okay. If you have completed, I will tell one more part of this question and try to do that. Completed? Done. So the same situation, but it has been connected with 400 volt. Same situation, it has been connected with 400 volt. What is resistance and what is current? Get it? The same situation, 100 watt bulb, now it has been connected with 400 volt battery. First, R is equals to, okay, then done. Okay, we'll go for the next one. Write down the topic, resistor in series combination. Resistor in series combination. The first point, resistor in series combination. Resistor in series combination. The first point, same I flows through each resistor, which means same current flows through each resistor. So till now we were discussing about the problems, no? If any junction is there, obviously I can take that as a parallel, which means current has been divided in two junctions. Okay, if current has not been divided in two junctions, I can consider that as series. Okay. Second point, the equivalent resistance greater than each resistor. The equivalent resistor is greater than each resistor. Next point, the sum of potential difference sum of potential difference in each resistor is equals to total potential difference. Next point, potential difference across a resistor is directly proportional to resistor. So from the equation I can say that V is equals to IR. So I will be remains constant. Okay, remains constant. So the equivalent resistance R series will be equals to R1 plus R2 plus up to Rn. This is my formula for the series combination. For capacitor it is opposite, 1 by C1 plus 1 by C2 plus up to 1 by Cn. So what is the third point says? The sum of potential difference in each resistor. Okay. The fourth point says okay, fine. Now I will go for application. So this is my resistors. For example, I will consider. So I have R1, R2, R3. So what is the equivalent resistor? R1 plus R2 plus R3. The equivalent potential is, let me consider the equivalent potential is this one, no, I will take that as V, okay, which will be directly proportional to the equivalent resistor. That is the point, no? V is equals to IR, so V is directly proportional to R. Any doubt here? Suppose the question is, what is the potential has been dropped only at this point they are asking. Can you get this one? This is the potential they have given, like from A to B the potential is V. So if I consider this point, like first point, this is V1 and this is V2 and this is V3. Only current is same, no? Potential will be different, no, for this one. What is the point I have told you before starting here? V is equals to IR, only I is constant. If R changes, V also changes. Yes or no? So obviously can I say like R1 V1 will be there, R2 V2 will be there, R3 V3 will be there. But for RS it will be V only. The sum of resistance will be directly proportional to the potential. If they are asking what is the potential only at V2, so I can write V2 is equals to V by R1 plus R2 plus R3 into R2. I will say how. We know that V is directly proportional to R, right? No? Can I say V by R is equals to constant? The total potential by total resistance I have taken. Listen carefully. The total potential is V and total resistance is R1 plus R2 plus R3. Is nothing but constant. If I talk about only this potential and this resistance, can I say V2 by R1 as I R2? V2 by R2, which is equals to again constant. I am using this equation only. Now can I equate the both constants? So V by R1 plus R2 plus R3 is equals to V2 by R2. So from this equation only I got this equation. So listen carefully now, I will explain once again. So series means nothing but R1 plus R2 plus R3 up to Rn, and we know that V is equals to IR is the Ohm's law. From that they have given that I is constant for the series. I is constant, the remaining two are not constant, it will be changes. Okay, the potential will be changed in the each resistance. Now we will go for the 3 resistor. So 3 resistor they have given R1, R2 and R3. What is the equivalent resistance? R1 plus R2 plus R3, right? Now what is the equivalent potential? It is V. So we got the potential and we got the resistance also, and we know that V is directly proportional to R since I is constant. So V is directly proportional to R1 plus R2 plus R3. I can write now. So if I take to the denominator, it will become constant. So again I am talking about only V2, which means I am talking about only R2. If I talk about only V1, I will talk about only R1. If I talk about only V3, I will talk about only R3. So V2 by R2 again constant. I can write like this also, V1 by R1 also I can write, V3 by R3 also I can write. So again everything is constant only. So from this equation I can equate both equation, this one. So V by R1 plus R2 plus R3 should be equals to V2 by R2. So the potential drop in V2 will be nothing but V by R1 plus R2 plus R3 times R2. This is how you will find the potential drop in each resistor. You can take this point. This is potential divider formula. Write on the next topic. Resistor in parallel. Resistor in parallel. Write on the first point. Write on the first point. The formula is 1 by R equivalent is equals to 1 by R1 plus 1 by R2 plus 1 by R3 for 3 resistance. So for n resistance it is up to 1 by Rn. Second point is the potential difference across the resistor are same. Potential difference across the resistors are same. So if I consider this is my V1 and this is my V2, either if I go like this also I will get V1 V2, V1 V2 and V1 V2. So in the parallel combination V is constant and in series combination I is constant. Okay. So from the equation I can say no, V is equals to IR. So V is constant. Since V is constant, I is inversely proportional to R. Yes, no? Right on the third point. The sum of each current sum of each current in each resistor is equals to total current. So listen here, if I talk about the current I, it has been splitted here, I1, I2, I3. Again coming to this junction it has been added, again I will get the same I. Okay. Now we will do a problem now. Write down. Find the effective resistance in the given circuit. Find the effective resistance in the given circuit. So we will start with the basic problem. Ten ohms and this is 5 ohms, again 10 ohms and this is 5 ohms. So B and this is A. Get the answer first. So what is the answer? Completed everyone? Okay. So please cross verify your answer here. So the first one will become 20 and the second one will become 10. So 1 by 10 plus 1 by 20, which is 1 by R equivalent. So 20 plus 10 divided by 200. Correct, no? 1 by R equivalent. So R equivalent will be equals to 200 by 30 one times, and this is one, like 10 and 10 will get cancelled off. So 6.6 and it will go on. So 6.6 ohms. 6.67. Completed? The next question is, find the current in each branch. Find the current in each branch. Find the current in each branch. So 3, 6 and this is 3 and this is 10 volt. This is the circuit. I need to find what is the current flowing in 3 ohms, 6 ohms and again 3 ohms. Each branch they are asking. Suppose the question they have asked in the examination, what is the current flowing in 6 ohms resistor. Then I need to find everything. Okay, listen, I will do this one. This is my question now. So this one can be getted in a parallel combination, which means 1 by 3 plus 1 by 6. So 1 by R equivalent is equals to 1 by 3 plus 1 by 6. So this is 2 plus 1 by 6. Correct, no? So R equivalent will be equals to 6 by 3, no? Which is equals to 2 ohms. Correct? So this is 2 and this is 3, which is nothing but 5. So again R equivalent, like R dash equivalent will be equals to 3 plus 2. Okay. So we got as a 5 ohms, the last one. So now we know that V is equals to IR. What is the value of V here? 10. And what is the value of R? So can I get the value of I? So I is equals to 2 ampere. We cannot stop up to this. They are asking in each branch. Now I need to go for the circuit. If you see here, if I take this as I is coming here and splitting into 2 parts. Let me take this as I1 and this is I2. Getting the point? Again it will be I only. If I talk about this 3 ohms resistor, the current flowing is how much? 2 ampere. But for the remaining 3 and 6, the different current will be flowing. Okay. Now I need to find what is the current there. Can I take V is equals to IR, since those two branches are parallel, potential will be same. I is inversely proportional to R, no? Then I1 by I2 equals to R2 by R1. Getting? So which is I1 and which is R1 we have taken? This is I1 and this is I2, and this one is R1 and this is R2. So please note that point. 3 and 6 and I1 and I2. So I1 by I2 plus 1 equals to R2 by R1 plus 1. Why I am taking is, listen carefully here, I1 plus I2 by I2 will I get, should be equals to R2 plus R1 by R1. What is I2 plus I1? I only know. So I by I2, what is R2? R2, 6 plus 3 by 3. Any doubt? What is I? 2. So 2 into 3 by 9 will be equals to I2. So which is 6 by 9 will be equals to I2. 2 by 3, it's I2 value. If I got the I2, can I get the I2 in this equation only? I1 by how much? 2 by 3 into, sorry, should be equals to 6 by 3. So I1 will be equals to 6 by 3 into 2 by 3, which is 12 by 9, 4 by 3. So 4 by 3 is the value of I1. If I club together 2 by 3 plus 4 by 3, 6 by 3. So 6 by 3 is 2. Am I getting the value of I now? Getting? So any doubt why I have added plus 1 and plus 1 here? For calculation purpose, it will be easy to get the value of I here. Okay. So these things you need to know when you are doing more number of problems. You can copy down. Resistors in disguised form. Resistors in disguised form. So disguised form is nothing but the circuit will be looking difficult, but when you try to understand the potential difference across the things, we can remove the nodes and we can remove the wires, okay, and it will be a simple circuit, okay. So we have completed the Wheatstone bridge problem also, no, like in capacitance we have completed the same concept, only we are going to see in the resistance also. R1 by R2 is equals to R3 by R4. When the ratios are same, in between whatever the resistance are there, I can neglect that resistance. Any doubt? The same concept, C1 by C2 is equals to C3 by C4. When the ratios are same, what I can do? Whatever the device, like either it can be capacitor, it can be resistance, whatever it is, I can neglect that, okay. Now write down the first one. Find the equivalent resistance. Find the equivalent resistance between A and B. Yes, question. Directly we go into question for this. Find the equivalent resistance between A and B. So this is my A and this is my B. Okay. So can you find what is the equivalent resistance for this one? Think. See, whenever they are asking the resistance in difficult circuits, no, let's mark this as some potential V, okay, V. So same wire, same potential V, yes, no, wire means same potential, no, but when I go across the resistor it becomes a different potential, V1. And this one, can I write this as V2? If this is V2, this also will be V2 only. Any doubt here? So can I take this one? This is my B and this is my A. I have taken like this, which means V1 and V. Any doubt? This is V, no? Oh, this is V2, okay. Oh, sorry. This is V and this is V2. Any doubt here? Now what is the thing there here? Again V. So can I take some resistor like this? This resistor I have taken. And what is the resistor in between this one? This is V, this is V, this is V1. So obviously this will be a parallel thing, no? V1, V1, parallel or not? What is the thing I told? Potential across the resistors are same, it will be a parallel. So some resistor is there. So this is my, let me take this is R and R. So this is V1. Any doubt? Once you can cross verify that. I have rearranged it, that's it. V1, V and this is V1 and this is V1. Any doubt? V1 and V1. Now what is the remaining things? Again V is there. I need to connect from here only, no? I will take here the same thing. V, what is there? V2. I'll draw one more resistor, V2. It has been connected to where? A, no? V2 has been connected to A. I'll take that to A, but in between V1 and A, I mean V1 and V2, no? V1 and V2, one more resistance is there. Now is this looking easy to calculate it? This is my parallel and this is my series, again this is my parallel, that's it. First what you should do is mark the potential either any one point. I'll take this as potential V. This is my wire. So since it's a wire, the same potential will be there. So resistor is coming across, so I'll change my potential as V1. So this is V means this V1 I have taken. Again I am going in this direction. So resistor is there, so it is V2. So I have completed these three things. Now this also completed, this also completed. So one more point is left out. So across this one, if it is, this is my V2. If this is V2, this also will be V2 only, no? So I have taken the first point as B, second point as A. So V and V2. So if I see V and this is V1 and this is V and this is V1, which means parallel combination. First I will draw that one. The next one is V1 is connected to A. So which means one more resistance in between there. I have taken that resistance also. And one more resistance is left out, this one. So it has been connected between V and V2. So this is V1 and this is V2. There is no use of that one, but V and V2 it has been connected. I have connected again. So this is the circuit. So can you get the answer for this circuit now? Get it first. Everything is R. R, R, and this is R, and this is also R. The next question is in the disguised form. So there is a 3 resistor. It has been connected with a battery. Now there is a wire in between these two, and there is a wire in between these two. Okay. Now I need to find what is the resistor, equivalent resistor. What is the first point? Mark any one as a potential V or V1 or V2, whatever you want. So let me take this as V. So this is resistor, but if I go across this one, like, it will be changed. But if I go in this direction, again it will be same or not. So let me take this as V only. So since I am crossing the resistor, can I take this as V1? If this is V1, I am going in the wire only, again this also V1 only. Is there any other thing left out? No. So V, V1, V1, V, V, V1. So same potential means it is parallel or not? This is my circuit, that's it. Getting the point? Mark the potential. If you are going in the same wire, potential will be same. If you are crossing the resistance, change the potential. Okay. So this is the points, and the next one is the infinity ladder, which we have seen in the capacitance only. Yes, no? If I talk about, there is a resistance and one more resistance is connected like this, so it is going on. So R and this is R, and the potential between them is, let me take as X. Okay, this is the thing we have talked now. If this is the potential difference is X, can I take this whole thing as X? Yes, no? So resistance, again one more resistance, and the other resistance is X, and the potential difference between them also X. Any doubt? So this is R and this is R. What is the series parallel combination? 1 by R plus 1 by X. So it is x plus r by rx. If I reverse the term, it will become r equivalent is equals to rx by r plus x or x plus r. So can I write the equation like this, I mean the diagram like this, rx by r plus x, and this is r. Is this in series? Yes, no? So I can get the value of x is equals to, the value I can get no from the equation minus b plus or minus root over 4, b square minus 4ac by 2a. Any doubts? The same concept which we have seen in the capacitance only we are using here also. Okay. The next one is Wheatstone bridge. So Wheatstone bridge, I have told you the relation R1 by R2 is equals to R3 by R4. If the ratios are same, you can neglect the in between circuit and you can do it. So when you are neglecting the circuit, what happens? It becomes series, and series at last it will be parallel. Correct, no? This is my Wheatstone bridge, let me take. So if some resistance are in between, if R1 by R2 is equals to R3 by R4, R1, R2, R3 and R4, if these are equal, I can neglect this resistance, which means this will be in series, this will be in series, and both are in parallel. Okay. Once you can copy down the remaining terms, we will see some more questions in the evening session.